Alright, we're here with another math video. We're carrying on with our similar shapes. So yeah, today we're going to talk about similar triangles. We've talked about things that are like this before. So when one shape is an exact enlargement or reduction of another shape, we say that these two shapes are similar. So basically, if one thing is a scale diagram of another, we say that they are similar shapes. So for example, the diagram of the ant below is similar to the actual ant because it's proportional in all directions. So again, we've seen that word before. That basically means it's stretched in the same by the same scale factor in all directions. So this diagram of the ant is proportional to the actual ant, meaning it is similar to the actual ant. So here are two similar triangles. We have this one here with the corners A, B, C. This one corners D, E, F. The capital letters at the corners are the names that we give the angles of these triangles. So we say this is angle A, this is angle B, and angle C. And we write this symbol here, which means angle. So that's angle A, angle B, and angle C. We also use these letters here to name the triangles themselves. So we would say that this one here is triangle ABC, and this one is triangle DEF. So that's what we say, and again we write it with this symbol here. This symbol means triangle, this triangle ABC, triangle DEF. And finally, we can use these letters here to also name the sides of the triangle. So for example, this side here, which is the line, is between A and B, so we would call this one line AB. Alright, and this one here would be line BC, and this one would be line CA. So AB is between angles A and B, BC between B and C, CA is between C and A. So we could switch the order of the letters without changing which side we're talking about. So we could call this one AC, this one could be CB. Again, that's just telling us which two angles the line is between. Now again, here's another word we've seen, corresponding. We've seen that term earlier in the unit. What does corresponding mean? We said that corresponding means similar in position. So on a triangle, matching sides are called corresponding sides. Alright, so name the corresponding sides on the following pair of similar triangles. We have the same triangles again. And since they're facing the same way, it's not difficult to see which sides correspond to the sides on the smaller triangle here, right? The bottom here is the same as the bottom here, so these two are corresponding sides. The short one here corresponds to the short one here, and this one corresponds to this one. So, like I said, line AB is on the bottom, corresponds to DE. BC would correspond to EF, and then CA would correspond to FD right here. So again, when they're facing the same way, it's pretty easy. Also, on a triangle, matching angles are called corresponding angles. So name the corresponding angles. Again, those are the angles that are basically in the same spot on these triangles. So at the top here, since they're facing the same way again, the top C is corresponding to F, which I have down here. A is corresponding to D, and B is corresponding to E. Pretty straightforward. One thing that you may recall here, how many degrees are there in all three of the angles of a triangle combined? Alright, so if we added up all three angles of a triangle, what would we get? We would get 180. So how do we write 180 degrees? It's the same way as writing degrees as a temperature. We use the little circle sign up here, so 180 degrees. So a reminder that this symbol here means degrees. So for example, we'll take a look at a bunch of examples here. Oh wait, I forgot this part here. What is the measurement of angle C in the image below? So basically what we have to do, we know that all three will add up to 180. If we want to find this one, we have to go 180, subtract these two combined. Okay? So I know that these two combined are 100. So I have to go 180, subtract 100. That's pretty easy to do. 180 subtract 100 is 80 degrees. So that means that 80 degrees is this angle right there. So that's how we do it. 180 subtract the other two angles combined. So for example, we want to name the following triangles. Alright, so again, we just take the three letters. We go J, K, L, and that's the name of the triangle. J, K, L. And for this one here, usually we go in order that they are in the alphabet. M, M, N, O. This would be triangle M, N, O. So a question, which side on triangle MNO corresponds to side JK? So JK is right here. Notice this one's not facing the same way, so it might be a little bit tougher. but it's not the longest side, it's not the shortest side, it's the medium side. So that's JK. That would correspond to, this is shortest, this is longest, would be this one here, which would be side MN. So JK corresponds to side MN. One more question here says, which angle on MNO corresponds to angle L? Well, angle L is right here. It's between the longest and the shortest side, so longest, shortest would be this one here, which is angle O. So I'll write angle O right there. Another example. Name all pairs of corresponding sides and corresponding angles of the triangles below. Alright, so corresponding sides, notice they're not facing the same way, so we'll need to do a little bit of thinking here. We'll start with the longest side. It goes from R to P. So I'll call this one RP. That corresponds to the longest one here is SU. Alright, and then the shortest one is from Q to R on this one, and the shortest one here is from T to U. Remember, the order the letters are in doesn't really matter. And then the last side here is PQ, and that corresponds to the short one here is from, ooh, did I do that one wrong? Nope, sorry, PQ is the medium one, and here ST is the medium one, so that's good. So those are all the sides that correspond with each other. How about the angles? So the angle Q here is at the wide point, that's like angle T, so I'll say angle Q corresponds to angle T. S is the small one, which is the same as P. I guess I should do it the other way around. P to S, and then that means we have R with U. A couple more examples here. Determine the size of the missing angles on the following triangles. So again, we combine the two angles we know, and we go 180 subtract that. So 36 plus 57. We go 36 plus 57 equals 93. So we go 180 subtract 93. So 180 subtract 93, we get 87 degrees. We do the same thing on this one, except for they only give us one angle here. But what about this one? That one's 90 degrees, so I combine 90 with 39, and what do I get? 90 plus 39 equals 129, and I go 180 subtract that. 180 subtract 129 equals 51, and that's the measure of that angle up there. So pretty straightforward. Combine your two angles, 180 minus what you get. Last example here. The following triangles are similar triangles. Determine the scale factor used to create the enlarged diagram to the right. So remember, when we're doing scale factor, we always go diagram over original, right? So we need to compare sides that are similar, right? So we know that this is the short side here, but we don't know the short side here, so we can't use 8. So we cross that one out. We know that this is the medium side here, but we don't know the medium side here, so again we can cross this one out, but we can compare the long sides. So we compare the 30 centimeters here to the 75, again diagram, which is this one, over original. So we go 75 over 30. This will give us the scale factor. So we divide. We go 75 divided by 30, and we get 2.5. So 2.5, I'm recording a video. 2.5 is the scale factor used to create this large shape. Yeah, these are the types of things you'll need to know for today's assignment. So don't forget to fill out the Google form, and I will talk to you later. Thanks.